Oil versus grease. When to use each? Hey, engineering enthusiasts! Today we're going to dive deep into one of the most fundamental and at the same time most neglected topics in mechanics, the difference between oil and grease. Let's uncover their particularities, understand their superpowers, and finally answer the crucial question. When should you use each one to ensure the best performance and the greatest durability for your machines and equipment? This is essential knowledge that goes far beyond the repair shop and applies even to the simplest home repairs. Have you ever found yourself facing a jammed machine, a squeaky hinge, or an engine that doesn't seem to be working as it should? And the first question that came to mind was, this needs lubrication, but with what? Maybe you have a can of grease in the garage and a bottle of oil in the cupboard, but do you know which one is best for each situation? Is it enough to just use whatever you have on hand? The truth is that choosing the right lubricant can be the difference between long, efficient equipment life and premature failure. First of all, we need to understand why lubrication is so vital. Think about two metal surfaces moving against each other. What happens? Friction, heat, and wear. In a short time, the part deforms, loses its functionality, and eventually fails. Lubrication is essentially the art of creating a protective film between those surfaces. This film can drastically reduce friction, control the heat that's generated, protect against corrosion, and even help seal against contaminants. It's the soul of mechanics, ensuring that everything moves smoothly and lasts much longer. But if the function is the same, why do we have two main types of lubricants with such distinct characteristics? The question is, what really differentiates oil from grease? And since this difference is fundamental, it determines the ideal application for each. To answer this, we need to understand the composition and behavior of each in action. Let's start with oil. What is it? It is, at its core, a viscous fluid that can be derived from petroleum, like mineral oils, or created in a laboratory, like synthetic oils. It contains a series of additives that improve its properties, such as resistance to oxidation, detergency, and the ability to withstand pressure. Its main characteristic is fluidity. The oil is able to move freely, penetrating tiny spaces and forming a thin, continuous layer between the contact surfaces. It's precisely this ability to flow that gives oil some of its greatest advantages. First, it's excellent at dissipating heat. In machines that generate a lot of heat due to constant friction, like a car engine at high speed, the oil circulates and carries this heat away from the parts, transferring it to the cooling system. Without this ability, overheating would be inevitable. Second, oil has a cleaning function. As it circulates, it can carry away small dirt particles, wear debris, and combustion byproducts, taking them to the filter where they are retained. This keeps the internal surfaces of the machine cleaner and free from abrasion. Third, its fluidity allows it to reach complex lubrication points, especially in systems that have pumps and lubrication galleries, ensuring that all moving parts receive their dose of protection. Internal combustion engines, automatic transmissions, hydraulic systems, and turbines are classic examples of where oil excels. So, in what kind of situation does oil prove to be the best choice? Basically, for applications that require constant cooling, removal of contaminants, and lubrication of components, that operate at high speeds, usually with moderate loads, and have a containment system to prevent it from leaking. The precision and efficiency of oil lubrication in these cases are unmatched. Now let's talk about grease. If oil is the agile fluid, grease is the robust paste. But what is grease? Actually, grease is a mixture. It is made up of lubricating oil, which can be mineral or synthetic, just like regular oil, along with thickener and additives. The thickener, which is usually a metallic soap like lithium, calcium, or sodium soap, works like a kind of sponge or matrix that holds the oil. Think of it like gelatin. Most of it is water, but the thickener or powdered gelatin makes it solid. The oil is gradually released, as the part moves or under specific temperatures and pressures. This semi-solid structure gives grease very particular properties. The main one is its ability to stay where it is applied. It doesn't flow like oil, which means it doesn't require a complex containment system. This makes it ideal for lubrication points that are difficult to seal or where frequent maintenance is impractical. In addition to staying in place, grease also acts as an excellent protective barrier against external contaminants. It seals the lubrication point, preventing the entry of dust, water, and other debris that could cause wear. In dirty or humid environments, this property is invaluable. Another advantage is the lower frequency of relubrication. Since the grease stays in place, the oil is released slowly, extending the intervals between maintenance. This makes it perfect for components that operate under heavy loads, low speeds, or intermittent movements, where cooling is not the main concern. Wheel bearings, universal joints, pins and bushings of heavy equipment, and even the hinges on your door are examples where grease is the right choice. But what about grease? What is its superpower and where does it shine? It is the champion of adhesion, sealing, and protection in challenging environments, especially when constant flow and intense heat dissipation are not the main requirements. But the question that won't go away, and that really matters for practical application: how do you actually decide between oil and grease? The choice depends on several factors related to the equipment and the operating environment. Consider the operating speed. For high speeds, oil is generally superior because it flows better and dissipates heat more efficiently. For low speeds, grease is more suitable because it ensures lubrication without being expelled. The load on the component is also crucial, where grease, with its consistency and ability to stay in place, is excellent for heavy loads, where oil could be squeezed out of the contact zone. For light to moderate loads, oil works very well. But what about temperature? If active cooling is necessary, like in an engine, oil is the way to go. Grease has a lower capacity to dissipate heat, but specific greases can be formulated to operate at extreme temperatures, both high and low, without losing their properties. Think about the working environment. If the place is very dirty, humid, or dusty, grease offers superior sealing and protection against contaminants. Oil, being a liquid, is more likely to allow these elements in unless the system is perfectly sealed. Lastly, the design of the machine and the maintenance frequency matter. If the component can't be easily sealed or benefits from less frequent lubrication, grease is the choice. If an oil recirculation and filtration system is feasible and necessary, oil is the best option. A simple rule of thumb to guide you: if the part can be sealed or bathed in oil and needs constant cooling and cleaning, go with oil. If the movement is slow, the load is heavy, the environment is harsh, or oil containment is a challenge, grease is the smarter choice. Let's look at some practical examples. Think about your car. The engine, a masterpiece of engineering that operates at high speeds and temperatures, is lubricated and cooled by oil. It has the function of containing the oil and a pump that circulates it throughout the entire system. The wheel bearings, which support enormous loads, are exposed to dust, water, and temperature variations. They rely on grease to protect them and ensure their reliable operation for long periods, without the need for a complex circulation system. And what about bicycle chains? They are often lubricated with light oils to allow quick and efficient movement, but these need to be reapplied frequently. On the other hand, certain parts of heavy industrial machines, such as large bearings, are designed to operate exclusively with grease due to the extreme load and the difficulty of maintaining a continuous oil flow. Using the wrong lubricant can be just as harmful as not using any at all. Putting grease in an engine, for example, would prevent flow, cooling, and cleaning, leading to overheating and catastrophic failure. On the other hand, using oil in a wheel bearing that was designed for grease would result in leakage, loss of lubrication, and the entry of contaminants, causing accelerated wear. The failure of a pin or bushing in agricultural equipment due to lack of proper grease can bring an entire operation to a halt. It is always essential to consult the equipment manufacturer's recommendations. They designed the machine with a specific lubricant in mind, taking into account all the operating variables. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like and turn on notifications. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be recognized in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description to access several opportunities to develop various skills that will make a difference in your career. And what about you? Have you ever had any interesting or challenging experiences when choosing between oil and grease? Which lubricant do you use most at home or at work? Share your story in the comments. I want to hear about your experience. Also, check out the 2 interesting videos on the side to learn more and satisfy your curiosity. If you'd like to support us, please like, subscribe, turn on notifications, and consider joining as a member. Thanks, engineering enthusiasts. Big hug, and see you in the next video.